This little video will cover the basics of enzymes and some of the nomenclature that you will need to know. So, what are enzymes? Well, enzymes are catalysts, and a catalyst is something that is able to speed up the rate of a reaction without itself being used up. So they're proteins that make reactions go faster. So for example, urea plus water will slowly degrade to carbon dioxide and ammonia. But if you put urease in, which is an enzyme, the actual reaction will be much, much faster. Now, there are a few RNA molecules that also act as catalysts, and they're sometimes called ribozymes, so they're worth noting. Now, enzymes often have cofactors that work with them and alongside them to make the reactions go a little bit faster. And so we have the term holoenzyme, that refers to an enzyme plus its cofactor. And those cofactors can be a number of different things. They can be a coenzyme, they could be a prosthetic group, or they could be a metal ion. So the cofactors act to speed up and work with the enzymes to get the reactions to go. So they quite often be organic molecules, they can be inorganic, and they can be prosthetics. So one of the most common organic cofactors is something called NAD+, or nicoamide adenine dinucleotide. It is two nucleotides joined together. It is a coenzyme in that it is required for the enzyme to work, but what happens is the enzyme will bind this cofactor, this coenzyme, to perform the reaction, and then the NADH will be released and replaced by a new molecule. So the molecule is needed to perform the reaction but isn't fully always bound to the enzyme. And an example of an enzyme that does this is lactate dehydrogenase, and it converts pyruvate to lactate. It requires NADH to do this and releases NAD+. So this NADH is the coenzyme in this example. Now, prosthetic groups are something that is permanently attached to an enzyme. Remember, coenzymes were only transiently attached. They came on and dropped off. So we talk about an apoenzyme plus its prosthetic group being the holoenzyme. Examples here are things like heme and metal ions. So if we look at cytochrome C, this is an enzyme involved in the electron transport chain, and it forms oxidation and reduction reactions, and it has a heme group located within its structure. So this would be a prosthetic group within a larger protein. Finally, we also have metalloenzymes. The cofactor in this case is a metal ion. I'm showing you an example of a zinc finger here. The metal in here is zinc, and it is coordinated, that is to be held in place by different side chains. Again, these are used to perform and carry out different reactions such as photosynthesis, nitrogen fixation. And one of my favourite ones is superoxidized dismutase. This is involved in removing free radicals that form during metabolism. It has both a zinc and a copper coordinated in its active site. That means they are bound by side chains. In this case, there are 3 histines and an aspartate residue. And it has the role of removing free radicals and harmlessly converting them into water. So a holoenzyme then is an enzyme plus its cofactor. When it's lacking its cofactor, we call it an apoenzyme, and those cofactors being coenzymes such as NADH, which transiently binds to the enzyme and is used up and is then replaced by a new molecule. They could be prosthetic groups like heme and porphyrin rings, or they can be metal ions. So these are all different types of cofactors. The enzyme without them is called the apoenzyme, and together they are called the holoenzyme.